Well, how about we talk about finding the area of oblique triangles? And fortunately for us, we have a formula that will help us do that, and it's called Heron's formula. So let's explore Heron's formula, and then we're going to work a couple of examples. Now, in Heron's formula, if we know the side measures of all three sides of an oblique triangle, we can use that information to find the area of that triangle. Now, I apologize that the formula is a little bit blurry. I recognize this. But to find the area, we can take the square root of S. We're going to talk about S in a minute, and I'm going to write this out. Times S minus A, one of the side measures, S minus B, and then times S minus C. Well, that brings us to the question, what is S? Well, S, we have a little formula for that too, which we find S is equal to 1/2 A plus B plus C, where A, B, and C are the measures of our side in this example, of all of the three sides, I should say. So we've got to find S first. Then we plug this in, we take the square root of all this, S times S minus A times S minus B times S minus C, take the square root of that, and shazam, we'll find the area of an oblique triangle. Do you want to look at an example? Well, I do. So we're going to. All right, well, let's see. Let's see what we got here. All right, we've got three side measures here. We got X is equal to 24 centimeters, Y is equal to 53 centimeters, and Z is equal to 49 centimeters. These are the measures of three sides. And so the first thing we want to do is we find S. Well, S is equal to 1/2 those side measures added together. So we got 1/2 times 24 plus 53 plus 49. And 24 plus 53 plus 49 equals 116. We take half of that, and that is 58. Now we're going to plug this into our area formula. And our area formula would state that we've got the square root of S, 58, times S, in this case, minus X, 58 minus 24, times S minus Y, 58 minus 53, and then S minus 49. So we got the square root of 58 times 58 minus 24 times 58 minus 53 times 58 minus 49. Well, if I take all that, that's going to end up being the square root of 187,340. Let's see, that'd be 58 times 48.5 times, no, excuse me, that's a different problem. 58 times 34 times 5 times 1 times 19. And that all equaled 187,340. We take the square root of that number, and our area is approximately equal to 432.8 centimeters squared. Make sure you include your unit of measurement. Shall we look at one more example? Why not? Here we've got our side measures are X is equal to 61 feet, Y is equal to 70 feet, and Z is equal to 88 feet. What's the first thing we need to do using Heron's formula? We need to find S. And so we're going to take where S is equal to 1/2 of 61 plus 70 plus 88. So here we got S is equal to 1/2, 61 plus 70 plus 88. Where S is equal to 1/2 times 219, which then equals 109.5. And then we're going to take the square root of, to find the area, we're going to take the square root of 109.5 times 109.5 minus 61, our first side measure, times 109.5 minus 70, our second side measure, times 109.5 minus 88, our third side measure. And all of that equals, where A is now equal to 450,154.438. Well, we're going to take the square root of that. And that's going to equal, and that should be approximately, not equal, 2,123.7 square feet. That's pretty fascinating. Heron's formula. We use Heron's formula to find the area of oblique triangles. Have fun.